All right, so these are the notes for Module 7A homework. We're going to work on the highlighted problems. For number 1, you're asked to find the value of this expression when z is negative 15. So everywhere the letter z is, we're going to replace that letter z with negative 15. So let's see what that'll look like. We'll have 6, and in parentheses our z is negative 15 minus 5 divided by z minus 4. Now our z minus 4 in the denominator, we still need to replace again the letter z with negative 15. So that'll become negative 15 minus 4. So let's simplify. In our numerator, 6 times negative 15 is negative 90 minus the 5. So I'll go ahead and simplify the rest of the numerator. Negative 90 minus 5 gives us negative 95 in the numerator. In the denominator, negative 15 minus 4 is negative 19. I'll just carry over the negative 19. Now, we want to check and see if these two numbers can be divided evenly, and they can. 19 can be divided evenly into 95 5 times. Now, why is our answer positive? Remember, a negative divided by a negative is positive. Let's look at number 5. We're asked to simplify this expression, and what I'd like you to do when you notice that your variables and your numbers are not in the same order, I want you to reorder them first. So let's reorder them so that we have our terms in the same order, meaning, see how in the numerator we have x first and then our constant. Let's do that same order in the denominator. So we're going to move the x term over to the left so that it's in front of the 6. Notice too the sign that's in front of your x. So when I reorder my denominator, that negative x moves to the front. And this is a positive 6, so we'll just write it as plus 6. The top expression will stay the same, x minus 6. Now you notice that these terms look very similar to each other. The only difference is that they don't have the same sign. We can rewrite them so that they have the same sign. What you do is choose either the expression in the numerator or the expression in the denominator, and you're going to factor out negative 1. It doesn't matter which one you choose. We're going to choose the numerator, and we'll factor negative 1 from both of the terms in the numerator. I'm opening my parentheses because I'm factoring negative 1. And when I factor negative 1 from x, I say, hey, what do I multiply negative 1 by in order to get positive x? And it'll be negative x. Negative times negative will make that positive x. Now, what do I multiply negative 1 by to get negative 6? It's positive 6. A negative times a positive will give us the negative 6. So we're left with negative 1 factored out. Inside parentheses, we have an expression negative x plus 6. And that looks very similar to the denominator, right? We just carry over the denominator, negative x plus 6. Now we can cancel these two terms, negative x plus 6. And what's left over is negative 1. That's our solution. So negative 1 we factored out. Let's look at number 6. Now for this example, you're simplifying the expression, which means we want to factor if possible and then cancel out any like terms. So in our numerator, we have 3x minus 6. We can factor 3 from the numerator. Now when we factor 3 from the expression in the numerator, we're asking ourselves, hey, what do I multiply 3 by in order to get 3x? And that's x. What do I multiply 3 by to get negative 6 minus 2? Now let's look at our denominator. X squared minus 2x. What can I factor from both of these terms? I can factor out an x. Now when we factor out x from the terms in the denominator, or x from x squared, what do I multiply x by to get x squared? That's x. Minus, what do I multiply x by to get 2x? 2. Notice your x minus 2 in the numerator and denominator. You can cancel those two terms out. So your answer would be 3 over x. Now let's look at number 9. Now number 9, you have b minus 8 in the numerator and b squared minus 64 in the denominator. So b minus 8, we'll leave b minus 8 as it is. Can't factor anything from b minus 8 other than 1. So we'll leave it as b minus 8. In the denominator, we have b squared minus 64. That's a difference of perfect square terms. And remember the way that we factor perfect square terms. We figure out the two terms that we are squaring, like I'm squaring b. So that will be b and b. And what am I squaring to get 64? What am I multiplying by itself to get 64? That's 8. So your factors should be b plus 8 and b minus 8. B plus 8 in the denominator times b minus 8. Notice your like terms. Your b minus 8 in the numerator, b minus 8 in the denominator. You can cancel those two terms out. Now you canceled out the b minus 8. You want to replace that space with 1. And in the denominator, you're left with b plus 8. This is your answer. All right, let's look at number 13. So we're multiplying these terms, and then we're going to simplify if possible. So let's just multiply across first. 14x times x to the 5th power will leave us with 14x to the 6th power. Now, how do we get x to the 6th power? Remember, this is a 1. So we add these two powers together because they have the same base. We can add 1 plus 5 to get x to the 6th power. In the denominator, 2 times 7x cubed would be 14x cubed. Now 14 and 14 can cancel each other out. And with our x to the 6th divided by x to the 3rd power, we're going to keep that base of x and subtract their powers. Remember, when you're dividing terms with the same base, you subtract their powers. So 6 minus 3 would leave us with x to the 3rd power. Now let's look at number 18. So in this example, you're dividing terms. So you're dividing terms, but remember, when you're dividing by a fraction, and that's what's happening here, it's the same as multiplying by the reciprocal. So you want to keep the same fraction here. You want to change this sign to multiplication, and then you want to flip the second fraction. So we'll keep the first one as it is. 12n squared minus 27 divided by 2n squared minus 5n plus 3. We want to change this symbol from division to multiplication. Remember, it's the same as multiplying by the reciprocal, but what is the reciprocal? We're going to flip this second fraction. So that means all the terms that are in the numerator, we'll move those to the denominator. And all the terms that are in the denominator, you're moving those to the numerator. That becomes n squared minus 8n plus 7 divided by 4n squared plus 4n minus 3. Now we need to factor each of these expressions. So let's start up here in our upper left corner. We have 12n squared minus 27. I can factor 3 from both of these terms. So we're going to factor 3. 3 from 12n squared. What do I multiply 3 by to get 12n squared? It'll be 4n squared. And what do I multiply 3 by to get minus 27? It'll be minus 9. So in the upper left of our second fraction, or our first fraction, we're going to replace those terms with 3 over 4n squared minus 9. Now let's look at the denominator. We have 2n squared minus 5n plus 3. I need to factor. So we're looking for terms that are going to multiply to give us the product of 2 and 3. So 2, 3, and 3 and 2 together. And then when we add them, we should get negative 5. So we can factor here our 2n squared. 2 is prime, so we know we can only factor it using 2 and 1. So 2n and 1n would be our factors. 3 is also prime, but look at our sign for that middle term. It's negative, so we want to make sure that although this is positive 3, we need to have 2 negative numbers in our factors. And when we multiply those 2 negatives, we still get the positive 3. So we know we would have done that part correct. So our 2n, let's factor is minus 3. Factor our 3 as 3 and minus 1. So those are our 2 factors. And let's carry over those factors here. 2n minus 3 and n minus 1 times, we're going to factor the top of our second fraction, so n squared minus 8n plus 7 will factor as n minus 7 and n minus 1. In the denominator, 4n squared plus 4n minus 3, our leading coefficient is not 1 again, so we'll factor, either you can factor as 4 and 1 or 2 and 2. Let's try 2 and 2 just because our number is so small in the middle. We'll factor as 2n and 2n. And then our minus 3 will factor using the term like negative 3. So we want to make sure that we do wind up with this positive 4. So we want our larger combination, that 3 and that 2, we want our 6 to be positive, right? So we make sure when we do our factors that we have that correct order. So we got our 2n plus 3 and our 2n minus 1. 2n plus 3 and 2n minus 1 would be how we would factor the denominator. All right, now let's see what we have here. Are there any terms that we can cancel? But before we begin trying to cancel, notice in the numerator of the first fraction, you have a difference of perfect squares. So we can actually factor this a little bit more. We can factor this 4n squared minus 9 a little bit more. Let's keep the 3 on the outside. And we'll factor 4n squared minus 9 as 2n. That's the perfect square number because 2 times 2 gives us 4. N plus, what do I square in order to get 9? That's 3. So it'll be 2n plus 3 and 2n minus 3. That's our difference of perfect square digits. Now the other terms will all stay the same, so I'm just going to recopy them. In our denominator of the first fraction, we have 2n minus 3 and n minus 1. The numerator n minus 7 and n minus 1. The denominator of our second fraction, we have 2n plus 3 and 2n minus 1. Now let's look and see which of these factors we can cancel. You see your 2n plus 3 and the numerator of the fraction on the left can cancel with the denominator 2n plus 3 and the fraction on the right, n minus 1 and n minus 1 can be canceled out. And 2n minus 3 in our numerator on the left side can cancel out with 2n minus 3 in the denominator on the left. And that's about it. So let's write our answer with the terms that are left. We have 3 left in the fraction on the left side, and that's in the numerator. On the right side, we have n minus 7 in the numerator. In the denominator, we're left with 2n minus 1 from the fraction on the right side. And this will be our solution. Keep these factors together. All right, let's look at number 22. For this problem, we're asked to simplify, add, and simplify. So when you're adding these expressions, think about what you know about adding and subtracting fractions. We know that we need to have the same denominator in order to add or subtract fractions. We already have the same denominator here, so keep that denominator and then add the terms in the numerator, b plus 2. And this will be your solution. So same denominator, keep the denominator, add the numerator because the plus sign is there. Let's look at number 25. So this time we're subtracting, but let's look closely at our denominators. Our denominators are the same. So we'll keep the denominator, x squared plus 17x plus 16. And this time in the numerator, we're subtracting. So subtracting is a little bit more work than adding because subtraction will impact the sign of the second terms. So 3x minus 7 in front will stay the same, 3x minus 7. And then minus 2x, that will become a negative 2x, minus 2x. Minus negative 8, that will become a positive 8. In our numerator, we can combine some terms here. We have 3x minus 2x. That leaves us with just 1x. And then we have negative 7 plus 8. That leaves us with plus 1. In our denominator, we can factor these terms. That's a trinomial that can be factored. That should be a 16. So x squared plus 17x plus 16, right? We're factoring this term. We want to find two factors. Well, when we multiply them, we get 16, but when we add them, we get 17. That'll just be the factors 16 and 1. And then x squared, we know we factor as x and x. So we can recopy the denominator using its factors, x plus 16 and x plus 1. The reason we want to use the factors is so we can cancel here. We can cancel x plus 1 with the numerator and denominator to simplify this problem. Remember, you want to replace any empty space with 1. And in our denominator, we're left with x plus 16. This is our solution. Let's look at number 27. So now we are still adding terms, but our denominators are not the same. If your denominators are not the same, what I recommend you do is rewrite the fractions on top of each other. You want them to be written vertically. So 4a over b plus 9b over 2. So we have to find our common denominator here. Now our common denominator, I'm trying to find a common denominator between b and 2. There won't be a combination. You can't do anything to b to make it a 2. You can't do anything to 2 to make it a b. Therefore, you have to multiply these two terms together. Your common denominator would be 2b. 2b. And now for the top fraction, what do I multiply b by? In order to get 2b, I have to multiply by 2. Now, because you're multiplying by 2 in the denominator, remember you have to also perform that same operation in the numerator. So I got to multiply the top by 2. 4a times 2 gives us 8a. In the denominator, what do I multiply 2 by in order to get 2b? You had to multiply by b. Therefore, you have to multiply the numerator by b. So 9b times b gives us 9b to the second power. Remember, you were adding these two together. Now that we have the common denominator, we would keep the denominator of 2b, and then we're just going to add these terms in our numerator. So we're adding these terms in the numerator. We have 8a plus 9b squared, and that's our answer. And that's the last problem from Module 7A homework.